Hi, my name is Ariana Cerro, and I will be reviewing the article entitled Randomized Clinical Trial. Gut microbiome biomarkers are associated with clinical response to a low FODMAP diet in children with irritable bowel syndrome. Just a quick outline of what this presentation will entail. I will go over the purpose of the study, give a brief background on irritable bowel syndrome and the low FODMAP diet, and then walk through each component of the research study, including the hypothesis, subjects, methods, and results, and then discuss some applications for clinical practice, the limitations, any conflicts of interest, and then I will conclude with a summary at the end. The purpose of this study was to determine the efficacy of a low FODMAP diet in pediatric IBS, as well as to determine if the gut microbial composition and the metabolic capacity are correlated with its efficacy. This was a randomized, double-blind crossover study. So just a brief background on irritable bowel syndrome, or IBS. It affects up to 20% of school-aged children. Symptoms can vary, but usually include abdominal discomfort, diarrhea, constipation, and bloating. There are a few different variations of irritable bowel syndrome, including IBS with constipation, IBS with diarrhea, IBS mixed, which is constipation and diarrhea, or IBS unspecified. The low FODMAP diet is thought to help alleviate the symptoms of IBS, and it eliminates fermentable oligosaccharides, disaccharides, monosaccharides, and polyols. These include sugars such as fructose and lactose, as well as fructans, galactans, and polyols. And you'll see from this list of foods, it includes things like dairy, wheat, onions, garlic, beans, avocados, and cherries, among other things. So the low FODMAP diet is thought to improve the symptoms of IBS because it decreases the microbial fermentation, which will lower the luminal osmolarity, which would be something that could cause diarrhea, and it will also lower the hydrogen production, which is thought to cause any discomfort, bloating, distension, flatulence, abdominal pain, and constipation. So the hypothesis of this study was that a low FODMAP diet would decrease the frequency of abdominal pain, and the efficacy of this diet was associated with the microbiome composition and metabolic capacity of the microbiome. So in other words, only specific microbiomes would respond best to this diet. The subjects were 52 children with Rome 3 IBS. They were ages 7 to 17 years old, with a mean age of 11.5 plus or minus 3 years. 33 children ended up completing both parts of the crossover trial. 22 of those 33 were female and 11 were male. 22 were Caucasian, 10 were African Americans, and 1 was Asian. And the breakdown of the different kinds of IBS was 24 with constipation, 3 unspecified, 3 with both constipation and diarrhea, and 3 with diarrhea. And the Rome 3 IBS diagnostic criteria includes recurrent abdominal pain or discomfort 3 days per month in the last 3 months, and 2 of the following symptoms, which can include improvement with defecation, a change in stool frequency, or a change in stool appearance. So the study design started with a 7-day baseline period in which the children ate their usual diet. They also had to complete a pain and stool diary where they would document how often they had abdominal pain, the intensity, and the location, as well as the type of stool that they were passing. After the 7 days, they had a 2-day of the intervention diet, which was either a low FODMAP diet or TACD, which stands for a typical American child diet. This was randomized, and during this intervention period, they also completed that pain and stool diary, and they also did breath testing on the second day for hydrogen and methane. And then they had a 5-day washout period, and after that 5-day washout, they did a second round of the intervention in which they were crossed over to the other diet, either the low FODMAP or the typical American child diet, and again had to do the pain and stool diary and the breath testing on the second day. Any of the participants that did not complete the pain and stool diary were excluded from the study. The low FODMAP diet and the typical American child diet were similar in the caloric composition as well as the protein and fat composition, and differed slightly in the amount of carbohydrates. They also differed in fiber, glucose, fructose, lactose, sucrose, maltose, and polylose, because those are their foods that contribute to FODMAPs. It's important to know here that all of the food was delivered to each participant by the USDA, and the participants had to return the containers of food with anything they didn't eat, so it could be weighed out to really analyze their intake. In addition, they tried to match the meals across both diets as best as they could, including things like regular milk versus a lactose-free milk, or regular soda versus a diet soda without any of the sucrose in it. The measures included the pain and stool diary that I had mentioned earlier. They had to describe their stool using the modified Bristol stool form chart for children, which I will get to in the next slide. They also had to document the number of pain episodes, pain location, severity, and duration of pain over 3 to 8 hour time periods. And this was measured on a Likert scale from 0 to 10, 0 being no pain at all, and 10 being the worst pain you've ever been in. They also had to document their GI symptoms, including abdominal discomfort, bloating, flatulence, nausea, and heartburn, and these were assigned a composite score. They were also scored based on a Likert scale. They also had to record the food they ate. And then on the second day of the intervention, their breath samples were collected, and they also extracted DNA from the stool samples to evaluate the microbiome composition. So the modified Bristol stool form chart, as you can see here, is just a way to classify your stool based on constipation, normal, or diarrhea, and there's different types based on the consistencies. So they broke up their participants into responders and non-responders. The responders were people who had more than a 50% decrease in the number of daily pain episodes during the low FODMAP diet. The non-responders showed no improvement during either intervention, and the placebo responders had over 50% decrease in frequency of abdominal pains to both diets or to just the typical American child diet. And the numbers next to each of those titles indicate the number of children that were categorized as responders, non-responders, or placebo responders. So for some results, in terms of pain and GI symptoms, there was fewer abdominal pain episodes during the low FODMAP diet when compared to the typical American child diet. There was fewer abdominal pain episodes during the low FODMAP diet and more during the typical American child diet compared to baseline. The median pain severity was lower in the low FODMAP diet with a severity of 1 compared to a severity of 4 during the typical American child diet. The composite GI score was lower on the low FODMAP diet in comparison to the typical American child diet. However, GI symptom score was not significantly different from baseline during either of the two diets. So moving on to the results in terms of gas production. Breath hydrogen production was lower during the low FODMAP diet versus the typical American child diet. There was no difference in the methane production in either of the diets, and the breath hydrogen production did not correlate with abdominal pain frequency. Responders had greater hydrogen production during the typical American child diet, but no difference during the low FODMAP diet. There was no difference in methane production, and hydrogen was sort of concluded to be seen as a fermentation marker versus a cause of symptoms. In terms of the microbiome, they found that at baseline, responders had more taxa with a greater saccharolytic capacity, which means that they had a better ability to break down sugars. The responders also had genes related to FODMAP carbohydrate metabolism, so the responders were more likely to have better results from a low FODMAP diet because they were able to break down sugars that would be in a low FODMAP diet as well as in a high FODMAP diet, which would cause the symptoms because they had a greater fermentation rate. In terms of the non-responders at baseline, they had Turrisibibacter, which was much lower in its ability to ferment carbohydrates. So removing fermentable carbohydrates from this diet will not improve IBS symptoms because this bacteria is already unable to ferment carbohydrates. So whether you add these carbs or remove them, it's not going to make a difference because they're not fermenting the carbohydrates in the first place, whereas the responders are fermenting carbohydrates and causing symptoms. The non-responders are already not fermenting these carbohydrates. Therefore, if you remove them, there will be no difference in the symptoms. In terms of applying this new research to the field of clinical nutrition, I think this is really showing a push for individualized diets, not just in the IBS population or in the pediatric population, but just in general, a more personalized approach to nutrition. So using your genetics and using your microbiome to determine what the best food is for you personally, and sort of doing these DNA samples to analyze what works best for you. I think that in terms of the pediatric IBS population, it would be really helpful if the low FODMAP diet was personalized to those who would benefit from the restrictions and those who you could predict would react well to it based on their microbiome. Since it is such a restrictive diet, I think it would really be hard for children to follow. And it also does eliminate some fruits and vegetables and whole grains, which are things that we want to encourage children to eat. So I would hate to put them on a restrictive diet and restrict those good foods from being eaten even more, such as those whole grains and legumes and low-fat dairy products or fruits and vegetables. So identifying which individual microbiomes would react best to the low FODMAP diet and prescribing those individuals the low FODMAP diet, I think would be really beneficial if it does hold true that specific microbiomes react best and could alleviate the symptoms of IBS. There is some concern that restricting FODMAPs for a long period of time could be detrimental to the gut because FODMAPs are good for increasing diversity in the colon, especially things like garlic or legumes. They promote growth of specific bacteria like Firmicutes, bacteroides, and bifidobacteria, which produce short-chain fatty acids, which are important for overall gut function. So this isn't something that you'd want to be on for long term, but instead you'd want to eliminate each of the food groups and then slowly add them back into your diet to see which ones bother you most. And again, if we can sort of identify which individuals would benefit best, then we could eliminate the potential negative cause that could be caused to the gut or just healthy eating habits in general. The limitations of this study was that it was a small sample size and it was also only performed in one single center. The participants were only on the low FODMAP diet for 48 hours, so I wonder if they were on the low FODMAP diet for a longer period of time, they would have showed different reactions to it. And I would have liked to know if there was a correlation between the type of IBS and their reactivity to a low FODMAP diet. So if those with IBS with diarrhea responded better or vice versa in any of the IBS categorizations. In terms of conflicts of interest, these researchers received funding from the NIH and Nestle Nutrition Career. The authors were also consultants for various companies such as Mead Johnson and Gerson Lerman Group. And it's interesting that Nestle just rolled out a low FODMAP nutritional drink and they funded this study. So just something to think about. In conclusion, this is the first controlled, double-blind, randomized trial in children, so there is need for more research. It does conclude that a low FODMAP diet appears to alleviate GI symptoms in children with IBS, specifically for those with the baseline microbiome that has increased saccharolytic capacity. But again, there is need for more research since this is the first of many research, I'm sure, to come out in IBS and low FODMAP diets in children. There has been some research in adults, but there hasn't been much research in children, so I'll be interested to see what comes out as low FODMAPs are a hot topic and increasing popularity in the overall nutrition world. And here are some references that I used during this presentation. And thank you for listening. I hope you guys enjoyed it.